This video is a lesson over particle movement and electrical fields. Okay, so we have three charged particles, and I've labeled them A, B, and C. And our three particles have an equal charge and magnitude, but as you can see, they're not necessarily, well, two of them are positive and one is negative. And particle C is the only particle that can actually move. So then we want to find out in what direction will particle C move. So when we're going to really look at this, we just need to find a direction. We don't need to find a magnitude for particle C and which way it will move. So let's say they could be a little different if the if the different charges had a different magnitude of their charge, but since they all have the same amount of charge, we don't have to worry about that. We literally just need to deal with what direction. So I'll draw kind of a dotted line here between A and C. And what this is because these two are positive charge, because they're like charges, they should repel. And so since they should repel, C would, if only it was acted on with A, it would move in this direction. Now if we draw a dotted line between B and C, we also see that these are opposite charges, so they should actually come together, so C would actually move in this direction. Now we need to find basically the equivalent of these two. And so the way you would do is you would assume these two directions are forces, and then you just add them, tip to tail. So really, if you go ahead and take one of these arrows and you put it on the other one, you would really get an end result force that would come out to about there. And so that would be the direction that C would actually move in. So this is if it's only acted on by A. And this is if only acted on by B. And this again is the sum of both forces, which will actually be particle C's path. So really, I guess I can explain this a bit more. So we know that that the force is the direction that particle C will move in. So like I said, that's that direction we were talking about. But it will not continue on this path. And the reason it's not going to continue on this path is because as it's traveling along in that direction, the forces should change. The distances there are between each other, and how and the actual direction. So like right now, B and C are like completely right next to each other, but once C moves downward some, that angle between them, it basically will change a little bit, and so the forces should point in a new direction. So this has been a video on particle movement and electrical fields.